Okay, guys, so in this video, we are going to take a look at one more example of using polar coordinates to compute double integrals. And in this case, we have to integrate e to the power negative x squared minus y squared. The region of integration is the region in the third quadrant that is between the circles, and it looks like the circle number 1 has radius 5 and number 2 has radius 7. Okay, so I will just use different scale here. So how about this is 2, 4, 6, 8, and this is the same thing, 2, 4, 6, 8. Okay, so the inside circle has radius 5. Hopefully you can see that, right? Because that's 25 is the radius squared. So this is going to be your inside circle at 5, right? So something like this. And then the outside circle is going to have radius 7. So that's just going to be right here. So it's between the circles like that donut. Okay, let's think of it as a donut. So something like that. All right, so the region of integration would be like between these circles, right? So that would have been if it was on the whole plane. But how does this, so if it was the whole plane, then the limits would be from 0 to 2 pi. But what I want to do is concentrate on what will happen if it was the first quadrant. Then theta would change from 0 to pi over 2, and hopefully you understand that because we are over here. So this is 0, this is pi over 2 over here, this is pi, this is 3 pi over 2, and then this is 0 or 2 pi. So back to 2 pi. So for the second quadrant, the limits will be pi over 2 to pi. For the third quadrant, the limits would be from pi to 3 pi over 2. And for the fourth quadrant, the limits would be from 3 pi over 2 to 2 pi. Or you can do negative pi over 2 to 0, either way, but I'm not sure which one it wants. So for third quadrant, you don't have to worry about that. Then that's just pi to 3 pi over 2. Okay, so that will be my theta limits. And then the radius would change. So if I were to fix a theta, right? So just imagine I fix a theta and just draw an array or whatever, and see how the distance to the origin changes for a fixed theta. So you can see over here, this is when the radius is 5, and then over here, this is when the radius is 7. So it'll go from 5 to 7. So that will be your inner limits. And let's see what we're trying to integrate. So how do we convert this integral to polar coordinates? So one of the things that I already told you is that in polar coordinates, x is going to be r cosine theta, and y equals r sine theta. But there is another very useful observation that sometimes is very helpful when you are dealing with integrals that have an expression x squared plus y squared. So in polar coordinates, so imagine that this is a point with some coordinates. This is x, this is y, this is your theta, and this is r. You can see here that by the Pythagorean theorem, x squared plus y squared is equal r squared. Now you can also see that here, because here you will have r squared cosine squared plus r squared sine squared. But if you factor out r squared, you'll get cosine squared plus sine squared, which is 1. So this connection between x, y, and r is very, very useful. Now, you may wonder right here, when you're looking over here, you see negative, so wouldn't that be a problem? Well, actually, no, it's not going to be a problem, because if I factor the negative out, I will actually get x squared plus y squared, right? So be very careful with that. Understand that you need both of these negatives here. Otherwise, you would not be able to do the trick that I am showing you, okay? So what are we going to do here? So let's convert. So first of all, I already know the limits. So pi to 3 pi over 2. And then for r would be 5 to 7. Now, this part right here, you should immediately recognize as r squared. So that'll be e to the negative r squared. And then we have dr d theta. Now, it is almost complete, but there is one other thing that we need to do. And that is remember the pirate. So pirate says R. Okay, so we do need that extra Jacobian here. And then we are ready to integrate. Okay, so let's submit that. Now let's continue with integration. Now this is splittable integral. In fact, it doesn't have a theta at all. So we can just split it as pi to 3 pi over 2 d theta. multiplied by 5 to 7 r e to the negative r squared dr. Okay, so this part right here, very easy because that's just theta. And I substitute pi, 3 pi over 2, which will just subtract them, and I will get 3 halves pi minus 1 pi, so that's just pi over 2. So that'll be from the first term. From this term, this is where I have to do a substitution. So this is substitution rule. So I need to know how to do that. So the way I do it is I just say, okay, let u be negative r squared. Then du will become negative 2r dr. Right? And so this r is really needed because if I solve this for dr right now, this will become du divided by negative 2r. So converting that, that will become r e to the u, and then instead of dr, I put du divided by negative 2r, right? Now you can see what happens here is that r is going to cancel, right? And so this is just going to be negative 1 half e to the power u, but e to the power u is e to the power u. It doesn't change. And then remember that u was negative r squared. And now I substitute 5, 7. So that's what's going to happen from the second integral if I do a substitution. So first let's substitute 7. So that gives me negative 1 half e to the negative 49. And then I substitute 5, but subtracting a negative is a positive. So that would be plus 1 half e to the negative 25. Okay, so let's just put that in here and see if that's correct. Okay. Yay.